Okay, so now we're at the what's the point portion of our lecture here, because we have been talking about that the valence electrons are the outermost electrons in the atom, and they are the ones that are going to participate in chemical reactions. So let's look at an example of a chemical reaction. And so what I want you to do is to watch this video here called Sodium and Water Pond on YouTube. All right, so go ahead and watch that, and just pause me, watch the video, and then come back. Okay, did you do it? So what you should have seen was that some teenagers took a fist-sized piece of sodium metal, and I have absolutely no idea how they got their hands on it, but they took that fist-sized piece of sodium metal and they threw it into water. And so it caused a chemical reaction with the water, because water is composed of oxygen and hydrogen. So it pulled those pieces apart in a chemical reaction, and it ignited hydrogen gas, and then that's what that explosion was. So that sodium is very, very reactive. Did you notice that in the video the kid was wearing gloves? Very, very good thing that he did that, because if he had held that piece of sodium in his bare hand, it would have started to react with the moisture in his hand, and he would have burned himself. So that sodium actually has to be stored in oil in a chemistry class, because otherwise it would start to react with water. Okay, so sodium is very, very dangerous by itself. So the question is, what's so special about sodium? So if we go back to our periodic table, find sodium on the chart, and so sodium is going to be Na, and you'll notice that sodium is in the first column. So that means how many valence electrons does sodium have? 1. First column, 1 outer electron. And so if it was to, now the magic number in chemistry is 8. Now you're saying, well, why isn't it 7? Why isn't it 6? Because of quantum mechanics. So it turns out that if an atom can get to the number 8, it's going to be very satisfied. All right? So sodium has 1 electron. How many does it want? It wants 8. Now what it could do is it could grab 7 electrons so that it gets to its magic number of 8. But it's easier just to give away 1 electron. So if it gives away its 1 electron, it then drops down 1 in its energy level, and then that energy level underneath it is completely filled with electrons, and so it thinks that it is a noble gas when it does this. So it thinks that it's the noble gas argon, because if you look at argon on that chart there, you notice that argon is going to have 8 outer electrons. So it thinks that it's going to be argon if it gets rid of that 1 electron. Now if it gives away a negative electron, what's the charge on the sodium now? So it's going to be positive. Now sodium doesn't care who it gives its electron to. Sodium and everything in that first column is highly, highly reactive, because all of the elements in the first column of the periodic table are trying to give away 1 electron so that they would think that they have this magic number of 8. And so what elements have achieved the magic number of 8? Right, so they would have 8 valence electrons. They would be in column 8. Those are the noble gases. So everything on this side of the, over here, that column 8, those are called the noble gases. They are very content because they have the magic number of 8. So that means that if you take any of those elements and you light a match and you stick it to it, nothing's going to happen. No explosion. If you have a balloon that's full of helium gas and you light a match and you put it to that balloon, you'll pop the balloon, but that helium would put out the match. No big deal. But if you had a balloon that was full of hydrogen, you got a problem. The Hindenburg. So think about the Hindenburg. It was a dirigible that was full of hydrogen and it exploded. Okay, that's because it's in column 1 and it's a very, very reactive element. So hydrogen, it wants 1 extra electron, so its magic number is 2. So for hydrogen and helium, their magic number is 2, and then for everything else, it's the magic number of 8 on the periodic table. Okay, so that explains, hopefully, why sodium is so reactive. Now, let's look at chlorine. So chlorine is going to be Cl. So find it on the periodic table. And you notice that chlorine is in column 7. So that means it has how many outer electrons? I heard you in the back. So yes, it's going to have 7 outer electrons. And what's it trying to get to? 8 outer electrons. The magic number is 8. So it could do one of two things. Chlorine could give away 7 electrons, or it could take 1. So it's in column 7. If it got 1 more electron, it'd be in column 8. And again, it would think that it's one of those noble gases. It doesn't really turn into one of those noble gases, but it would think that it is one. And so chlorine is very reactive because if you breathe in chlorine gas, it's going to take an electron from your lungs. And then your lungs will not operate chemically the way that they're supposed to because they've been ionized by the chlorine gas. So you choke and you die. So back in World War I, chlorine gas was used as a chemical weapon. Chlorine gas is very, very reactive. If you were to have chlorine gas in the room around you, not only would you die, but it would also start to eat away at the paint on the walls because it will react with anything. It's very, very reactive. All right, so now we've got that chlorine is going to want to give away, it's going to want to take an electron. So if it takes that electron, which is negative, it's now going to be a negative chlorine. And so opposites attract. So if you have a positive sodium and a negative chlorine, they're going to go together and it's going to make sodium chloride, which is table salt. So that's an example of a chemical reaction. You've got one atom that is saying, take my electron. The other one is saying, Santa Claus has come to town. I want your electron. So it's a match made in heaven. And so this one is now an ion. This one's an ion. Opposites attract. You make the molecule or a compound sodium chloride, which is ordinary table salt. Now you might be wondering, what's going to happen if I eat my French fries that have salt on them? Am I going to explode? No. Okay, remember we said a ion of an atom has completely different chemical properties than the original atom. So that sodium, the original atom, is very, very reactive. but sodium ion is not. And chlorine, the original atom of chlorine, is very reactive, but chlorine, when it's been ionized, is not. And so whenever you eat your French fries that have salt on them, what will happen is the sodium and the chlorine will separate into their ions. And those ions are okay inside your body. As a matter of fact, your body needs to have ions in there in order to make your muscles and your heart to be able to work. But that's biology, so don't worry about that. Okay, let's take a break, and when we come back, we're going to talk about chemical bonds.